Please join me in welcoming back my friend, Dr. Craig Smith.
Thank you. Thank you all. Thank you very much for coming. It's a great honor and a pleasure for me to be here at Beckman Center in this wonderful facility. And to those of you who I can't see who are in the annex, wherever that is, thank you again for coming. And I hope that you'll be able to follow the lecture in the other room. Sorry that we couldn't get everybody in the auditorium. So I'd like to start out by talking a little bit about the concept of building the pyramids, and I think I'll start with this, with Hollywood's version. Can you all hear me okay in the back of the room? Okay, thank you. So Hollywood's version, most of you in this room are too young to have seen this movie. Maybe a few have. But, it was slaves moving this giant statue weighing hundreds of tons under the cruel whip of the overseer. And then one guy falls down, and suddenly one guy turns around and stops this huge thing from moving. Only in Hollywood, right? But in reality, it wasn't slaves that built the pyramids. That's something that Hollywood started, I think. It was people that were paid with beer and bread, like our graduate students today. Anybody here from UCI, they know what I'm talking about. But we know a lot more now about this because of the recent work, which I'll touch on a little later, excavating the workers' village, where workers actually lived when the pyramid, the Great Pyramid and the other two pyramids were built, and then from excavating the tombs of the workers as well. So just to bring you up to speed, as it were, on the site at Giza, the three large pyramids there. Maybe a quick show of hands. How many of you have been to Giza and seen the pyramids? Oh, wonderful. Quite a large number of people. So the Great Pyramid, the Pyramid of Khufu, up there on the upper right. And then this pyramid in the center, the pyramid built by the pharaoh Khafre, who was Khufu's son and inherited the throne after he died. And then Menkare's pyramid, the smaller of the three, Menkare being Khufu's grandson. So there are three generations of pharaohs buried there at Giza. And as you approach the pyramids from the western desert, this is not the normal way you would come to the site, but you begin to get an idea of the immensity of these ancient structures. And coming even closer, you begin to see the size of the stones. And in this illustration, you can see some people climbing on the pyramid. These little white dots are four people going up. The fourth dot's not white. The guy took his shirt off. But that's not allowed anymore. Too many people have fallen and been seriously injured or died. Also, I want to call your attention in this slide to one other interesting feature. You notice that the heights of these various courses of masonry are not all the same. So here you have some bigger blocks. They get smaller. Up here's some real tall blocks. They get smaller. Some more tall blocks here. And I will come back to that a little later, the significance of that. Also, you notice that these blocks all look different. And certainly they are different in size. And you might bear that in mind when you read some of the articles that have come in the paper lately about the pyramids being built out of precast concrete blocks. Seriously, there's serious people that propose that. So here I am standing on the first course of masonry. These blocks here weigh about 15 tons. They're 1.5 meters high, about 5 feet high. The next ones are 1.25 meters high, then 1 meter, and so on. And so you see right there the progression of size. Now, to put this into some kind of perspective as to what you might compare it to, something we've all hopefully seen, I sort of transposed it on Hoover Dam. And the base of the pyramid is about as wide as Hoover Dam is thick. And It's not quite as long, and it's about 2/3 the height. But just to give you an idea, Hoover Dam, by the way, took about 5 years to build, average workforce of about 3,500 people, maximum workforce of about 5,000 people, and several hundred people died in building Hoover Dam. Do what? Oh, I'm using this microphone here, in theory. Okay. Is it bothering you? Okay. All right. Maybe a little more volume? Maybe a little more volume by me. So the other thing I want to mention in comparison is the Washington Monument. The Great Pyramid was the tallest man-made structure until 1885, when the Washington Monument was finally built. How is it now? Okay? Please raise your hand if you think it's still not good enough. So why build this pyramid? Well, it was built for this man. This is the only known likeness of the pharaoh Khufu. This is a little ivory statue about so big in the Cairo Museum. And the pyramid was built by this man. He functioned as the project manager or program manager, as we would call it today. He was actually Khufu's vizier, his cousin, which also probably was helpful to him. And he had multiple titles. He was in charge of the taxation system and the courts, and then also called the overseer of the king's works, buried in a very special tomb right behind the pyramid. Now, why build pyramids at all? Well, pyramids became burial sites. They evolved to become burial sites. So the tradition in ancient Egypt was, in the very earliest times, the dead were buried in the desert, covered with stones, in a fetal position, facing west in the direction of the setting sun. Those tombs then became more elaborate and were covered with flat stones and eventually called mastabas, the Arabic word for bench or step. And someone got the idea of putting more steps on, making a more elaborate tomb, and this was known as a step pyramid. And in the case of the pharaoh, who at this time was considered to be the representative of the gods on earth, metaphorically, this was the means by which the pharaoh could ascend to the heavens and communicate with the gods on behalf of the Egyptian people. Somewhere down the line, and we don't know exactly what brought this about, but the design evolved into the true pyramid, and these steps were filled in to give it a smooth surface. So by Khufu's time in the 4th dynasty, the pharaoh was now considered to be divine in his own right, so metaphorically he didn't even need the steps to ascend to the heavens. This is an example of a mastaba. This is at Meidum. It had multiple tombs. As you can see, each of those black spots there are entrances to individual tombs that were robbed in ancient times. And the most famous step pyramid is Djoser's pyramid at Saqqara. And here you see the steps. If you look really carefully, you can see here a line, a construction line, where at some later point the size of the pyramid was increased. They actually added another step on top and amplified the side of it. Under this pyramid, there's an extensive labyrinth of corridors and chambers. Nothing in the body of the pyramid. So following this, then Khufu's father, the pharaoh Seneferu, built 3 large pyramids. The first was at a site called Meidum, and the pyramid collapsed. We don't know whether it collapsed during construction or shortly after, but all that remains is a big pile of rubble and the central core of the pyramid. So Khufu moved his operations to Dashur, and started to build another pyramid, which you see here in the photograph. And as the construction rose up to about the halfway point, things began to settle. The chambers inside started to be collapsing, ceilings cracking. And this was the first time when an effort was made to actually build chambers in the body of the pyramid. Prior to that, they were always in the bedrock underneath the pyramid structure itself. And so the builders were faced with a quandary of what to do, and they decided to change the slope so that to reduce the weight on top of the structure. And this site, I looked at this very carefully, and there are excavations around the side, and you can see it's very sandy soil. It simply did not have the bearing capacity for this huge mountain of heavy stone, and that's why it settled. So, undeterred by this, Senefru went on to build a third large pyramid at the same site. Here you can see the bent pyramid in the background about a mile away. And the new pyramid was called the Red or North Pyramid. Red because of the reddish limestone that was used in it. And up here you can see the entrance to it. And if you go inside, you go down a long sloping corridor, and you find this chamber. This is one of my favorite photographs. It's this beautiful stonework in pink limestone. And the ceiling, you see, is corbelled. Corbelling is where the builders build a vertical wall, and then they move it in a little bit, and then another vertical section, and move it in a little bit, and then another vertical section, and so on. So the ancient Egyptians did not have the concept of the arch. And then here's a door. This leads out and into another corridor and up to a second chamber identical to this one at right angles to it. And then out of the very top of the second chamber is another hidden little door that leads into a third chamber like this, which was the actual bearing spot. So Khufu's father was responsible for building these three pyramids, and if you look at them, and both in terms of the slope and the height and so on, it becomes evident that they were, in Khufu's mind, prototypes for what he wanted to do. And as you'll see later, what he wanted to do was to build bigger, taller than Dad. So what did the Egyptians know about design? There are no drawings or blueprints that have ever been found of the Great Pyramid. There are sketches like this made on scraps of stone. This is a floor plan for a temple. Each of these dots or squares represent columns. So it's clear the Egyptians had the concept of design. There are also stone models of pyramids that have been found. And as far as tools, they invented many of the tools that we would find common today. They used wooden mallets, copper chisels for cutting limestone. They had drills, brick molds, and so on. They did not have any iron tools at this time, nor bronze. One of the remarkable things about the Great Pyramid is the accuracy with which the construction was performed in terms of leveling the site, orienting it, keeping it square, maintaining the slope, and all of these things. And this was done with instruments like this. And outside, after the talk, if you want to stop by where the refreshments are, I have some replicas of these instruments that you're welcome to take a look at. The cubit rod, which was defined as the distance from the pharaoh's elbow to his outstretched fingertips. And, of course, you all know about the cubit from the Bible. And then this is a vertical level for making sure columns or walls are plumb, and then a horizontal level. I mentioned earlier we know a lot more about the workforce because of this recent work. Mark Lehner here is an American archaeologist, a wonderful guy, He's been working on excavating the workers' village, which lies just outside where the pyramids are. And from that, we've learned a lot about the number of workers that lived at the site, how they lived, what they ate, and so on. This is some of the drawings that Mark has developed of this workers' village. And this is a tremendously challenging work. He goes there in February with a group of students and with Egyptian participants and uncovers a section of this at a time. This is right near the village, so undoubtedly part of it's covered up by modern buildings. And here's a soccer field. There used to be a riding academy out here. People rode horses through here. But every year he excavates a certain part, maps it, photographs it, and then he has to cover it back up again to prevent it from being totally ruined. This is another workers' village. This is in the Valley of the Kings at a place called Deir el-Medina. This was more recent times, but it's similar to the village that was built at Giza. And from Deir el-Medina, there were a lot of interesting records obtained that were payroll records for workers, told what they were paid, records that showed when they didn't show up on the job. So-and-so had a fight with his wife. Joe came drunk to work. Stuff like that has actually been recorded. So it's fascinating, the history of some of the labor issues. And then Zahi Hawass is working on, among other things, the excavation here of the workers' tombs. This, again, is right behind the pyramids. And if you look at some of the individual tombs that have been excavated, they're like miniature pyramids in themselves. So inside these tombs, they have found descriptions of the workers' responsibility, like so-and-so's head of the carpenters on the north side of the pyramid. And many of these graves have father, son, and grandson in them, 3 generations of people who worked at this site. So where did the stone come from? Well, based on the experience Khufu's father had at Dashur, he no doubt had his architects find a better site, and Giza was an ideal site to build on. You have this huge limestone formation that extends. This is the back of the Sphinx right here. Extends from the back of the Sphinx on up at a gently sloping angle up to underneath the Great Pyramid. Not only did it provide a very firm base for the construction, but it provided an ample source of raw material right at the site. And if you walk into the back of the ancient quarry, which is right in that area between the pyramids and the Sphinx, you can see these stone faces where the stonemasons had cut out stone blocks used to build the pyramid. These holes here are tombs that were made in more recent times. And I found this example of a block in my perusing in the quarry. And here you see, let me go to the next slide. This is the top view of that block. That's my briefcase there to give you an idea. And what happened here is that the masons are standing here like this with a stone axe, hewing out this channel. And they would cut around the block on all 3 sides. Here it's been filled in with some rubble. And then in front, cut these niches. Here you can see where it was cut on the side. And then they pound wedges in there and basically pop up this block and then move it onto a wooden sledge. And then they would dress it to finished dimensions in the quarry and then haul it up to put it on the ramp and up onto the construction site. This is a block, an abandoned block in the quarry, and this is a special kind of stone called dolerite, a very hard stone, which was used in polishing limestone, but more importantly used in cutting granite, because the stone and copper chisels would not cut granite. This is a wonderful site. This is something called the unfinished obelisk. This is up at Aswan, about 500 miles south from Cairo, from Giza. And here in the granite quarry, the Egyptians hewed out this huge obelisk. This weighs about 1,000 tons and 150 feet long. And this was done by taking these balls of dolerite and just flaking off the granite bit by bit. And if you climb down in this ditch on the sides of it, where they've excavated, underneath you see it's sitting on a little stem, sort of like a mushroom. So once they were done, they would light a fire down there, heat the stone up, and put cold water on it until it cracked. And then they had to move this mammoth thing out of here down about half a mile to the Nile River. Unfortunately, as they were finishing this, it developed this crack right down the middle. And so all that work was wasted and lost. And the obelisk was abandoned there, certainly to the workers' dismay, but to our good fortune, because now we could see how they did this. In the hillsides around here, you can see where many granite beams were cut out and shipped down the river and ended up in the Great Pyramid. This gentleman is demonstrating one of the stones of dolerite that was used to cut the granite. And across the river from Giza is a place called Tura, and this is a modern quarry at Tura. And you see here this nice white limestone. That was what was used to encase the pyramid originally. And you can picture how beautiful that would have been, dazzling in the sunlight, when it was all present. Of course, today it's all gone. It's all been stolen over the ages and incorporated into Cairo or burned and made into cement. So how do they move the stones? Well, by ramps. There's ample evidence of ramps, of physical evidence, ramps remaining, such as this one, remains of ramps, or drawings and formulas for calculating the slope and volume of ramp. Now this one shows some mud brick retaining walls, and these marks here were where wooden beams were laid across so that you could drag the sleds up and with less friction. Here's a ramp probably used in the construction of this Queen's Pyramid here at Giza. Another ramp used in the construction, no doubt, of this mastaba. This is behind the Great Pyramid. A long causeway leading up to Khafre's Pyramid. And this is an interesting one. This is actually Karnak, and this is the remains of the ramp used to build this temple wall. And you see these reinforcing walls of mud bricks that were placed, and then it was filled in with sand and debris. And for some reason, this part of the ramp remained. It was never totally removed. It's one of the unique cases where we can see what the actual method of construction was. Now, one thing we know the Egyptian didn't do was build one single ramp to the top of the pyramid, something like this, because that would have taken 3 times as much material as it took to build the pyramid itself. And the Egyptians were very skillful builders, so they wouldn't have done that. So what I believe they did was build a ramp up to what I call course 55, about a third of the way up the height of the pyramid, given that there's 210 courses of masonry clear to the top. So at that elevation, they were able to have all the major internal features, the chambers and corridors completed, all the beams and so on, the heavy materials were in place, and the biggest blocks were in place. And given that it's a pyramid, by the time you reach a third of the height, you have over half the blocks in place. And that ramp had to be wide enough to allow multiple teams of workers to drag these blocks up the ramp and put them in place. Then from then on, a ramp was built off the structure itself. So you can picture now the ramp has to rise as the structure rises itself. And at this point, the blocks are smaller. There are fewer blocks, so you don't need the width that would be shown in the other ramp. And then finally, at the very top, you don't gain enough elevation with this ramp, and so then just a stair-step type of structure was left in place, and the last few blocks manhandled. So here's a little animation to illustrate how that might have looked. And you can see the ramp has to rise as the pyramid itself is rising. And once the structure reaches the very top, then at that point the masons begin putting on the casing stones to give it the smooth finish. And from the top, then they work their way back down and demolish the ramps as they come down. So it's interesting that the ramps themselves were a great construction project, and of course at the end that had all be cleared away to finish off the site. Now on the north side of the quarry, if you walk in there, you see this, some of the faces of the quarry. This would be the side closest to the Great Pyramid. And looking at this soil, this is my faithful, loyal assistant, by the way, my wife. If you look at this, you notice this is not undisturbed soil. And what she's smiling about here is it's just flecked with pieces, hundreds of thousands of pieces of 4,000-year-old pottery. Pieces of pottery from beer jugs and bread bowls, chips of limestone, sand, clay, dirt. In other words, this is all the material that was used to fill in the ramps. And what would you do once you were done with the ramps and were going to get rid of them? Well, the easiest thing to do would be to just push them over into the hole that you made when you took the limestone out. And so that's what I believe is debris from the ramps. So some aspects of construction. When the pyramids were being built, before the Aswan High Dam was built, the Nile would flood almost right up to the base of the pyramids, as this old photograph shows. So the Egyptians built a canal and a harbor there and brought goods in by boat. Now this is something I found on my last trip to Egypt, which fascinated me. We were in Karnak and looking in some temples there in Karnak, and I found this unusual panel carved in the wall. And what you see here is the pharaoh and the goddess, and the pharaoh is pounding in a surveying stake, and here is a cord, and this emulates the ceremony that I describe in my book because I knew about it from my research, but I hadn't seen this at the time. But at the start of a project, the pharaoh would undergo a ceremony called stretching the cord, where he would put a rope or string around the boundary of the site that would delineate where the construction was to be placed. So here I found this wonderful carving of this. And then there are 3 panels. In the second panel, here you see the pharaoh throwing out a bucket full of sand under, again, the eyes of the goddess. So this is analogous to our ceremony today of the first shovel full of dirt. And it's interesting when you think about the city builds a new fire station and the mayor's there with his silver shovel throwing out the first spadeful of dirt. This goes back to some ancient Egyptian ceremony of 4,000 years old. And then the third block in this sequence of carvings was this one, which shows the pharaoh bringing the first building blocks to be blessed by the god to start the project. So it's like laying the cornerstone of a building today. Now, I mentioned earlier that one of the remarkable things about the pyramids are their orientation. They're all, at Giza, all oriented very precisely with the major axes north-south and east-west. So the question is, how was that done? And there are 2 theories about that. One is that it was done by sighting on a North Star. And you can read about that in several books. I thought that was more difficult in my mind for the ancient Egyptians to do because they didn't have any optical instruments. The other method is something called the sun shadow method, and basically what that involves is putting a vertical post and tracking the sun's the shadow and marking off an angle and then dividing that, and you can find true north. So I tried this myself down on the beach at Newport where I live. It's about the same latitude as Giza. And there were a few people that thought I was a little crazy. Well, I am a little crazy. I wouldn't be here. At any rate, I found I could set a north-south line accurate to about 1 degree, whereas the Egyptians were able to do it accurate to about 1 minute of a degree, about 60 times better than I could do it. But it was enough that convinced me that this would be a feasible way to do it. And now, along the pyramid on the east side, this at one time was a beautiful courtyard, and you notice a lot of the paving stones have been removed. And this is bedrock here. And so in the bedrock, we found these curious square plugs. And I discussed this with Mark later. We had several conversations about what this might have been. And finally concluded that these were at one time benchmarks. So there was a post put here, and these line up very nicely north-south. And so the surveyors put these marks in to orient their construction. And at the corners, there is a big cornerstone like this, and more of those marks. You can't see them in this slide, but out here in a pattern whereby, if you remember taking high school geometry or something, you take your compass and swing some arcs with a compass on a piece of paper, you could create a right angle. And so from that, and those marks show that that's what they did, then they could establish an east-west line. Then after the site was rough leveled, and they didn't bother to level everything. In fact, on the northeast corner of the pyramid, there's a big rock outcropping that goes up about this high that's actually incorporated right into the structure. And they just cut it into these steps, so it fits right in. But they rough level it, and then they put this layer of stones called platform stones that are exactly 1 cubit thick, and they fine leveled all of that so that the structures, it covers about a 13-acre site, just the base of the pyramid, and that whole base is level within plus or minus about a half an inch. Pretty amazing. Now, in Menkare's pyramid, the smaller pyramid, the third pyramid, in the 500 or 600 years ago, some Arab grave robbers came and decided to try to find their way into that pyramid. And their technique was to climb up on the side of it, place a large charge of black powder, and blow a big hole in the side of it. And they didn't actually find the entrance in doing that, but they left this big gaping hole in the side of it. So I obtained permission from Zahi Hawass to go up and look at that, because I wanted to see what the interior construction was like, and that was the one place where you could see the inner stones. And lo and behold, I found this surveyor's line written, painted here on the rock. This is a red kind of paint that masons use when they're cutting stones also. So this line is, 4,000 years old, and it's slowly fading because of exposure to the weather. And also, here was a vertical line lined up right at the center line of the pyramid. So I've never seen photographs of these before. I thought this was really interesting because this shows how the masons, as they're building out, are marking the stones and lining everything up and continuing to make sure it's accurate. Also, you look in here and you can see these stones. These don't look like the stones in the Mayan ruins, do they? They're all kind of odd shapes and fit together, and they're not. The internal stones are not precisely cut. Also, anybody that's worked in construction would say that those don't look like precast concrete blocks either. So the stones were put on wooden sledges that were dragged up the ramps, and in some cases maneuvered with wooden rollers. This is a classic tomb painting that shows 60 men moving this, 172 men moving a 60-ton statue on a wooden sledge. And here's a guy up here who's beating out a cadence for the laborers. And this guy is pouring some kind of fluid under the runners to lubricate them and make it move more easily. So this is an artist's representation. What it would be like to bring those blocks up on the lower courses of masonry where their blocks are 10 or 15 tons. Now, how did they do some of the chambers and internal structures? This is an example of how I think the Queen's Chamber was built. So they built a flat surface up to the level where the Queen's Chamber was. Then they built the walls of the chamber and then filled it full of sand. So they had a flat working surface and built a little auxiliary ramp and then dragged these beams up and put them in place. And once that was done, then they sent some workers in and dug all the sand back out to empty out the chamber. So they used that same technique to lower a sarcophagus down into a deep shaft for a vertical tomb. So you might have a stone sarcophagus weighing 3 or 4 tons with a vertical shaft. They'd fill the shaft up with sand, set the sarcophagus on it, and then just slowly dig the sand out and just allow it to sink down 30 feet into the ground. So very clever ways they did things that they could accomplish with lots of labor and lots of time and probably lots of beer. Then the finished stones, the casing stones on the outside were trimmed along one edge, as you see here, to the right angle. In the case of the Great Pyramid, it was 51.9 degrees. And they were rough trimmed on the surface, and then as they were all put in place, and masons went over and smoothed it all off to make it look uniform. So now let's take a tour down inside the pyramids for those of you who haven't already done that. And I want to come back for the moment to this graph which shows the height of every course of masonry. As I mentioned to you earlier, they're not all the same height. And here you see 1.5 meters, 5 feet high for the first course, and 1.25 meters, and so on. Now this is data that was gathered in the 1800s by a British archaeologist named William Flinders Petrie. And I chose to use it because it was at a time when the best modern kind of measurement techniques were available. And the pyramid had not suffered some of the degradation from weather and people climbing on it and so on that it has suffered in the last 150 years. So I thought this would be more accurate. Petrie was quite a character as it goes. He lived in an abandoned tomb at the site and liked to come out and make his measurements at night when there were no tourists around, and he'd be seen wandering around the site in his pajamas, or rather a nightgown, I guess would be more appropriate to say. But anyway, what I found was that these main courses with the bigger blocks lined up very nicely with some of the internal features, so I view them as sort of structural reinforcements at the levels where things were happening. And you see, once you get about halfway up, above course 100, then all the blocks here are just a little bit, just very close to 0.5 meter high. Now they only weigh 2 to 3 tons. And what is 0.5 meter? 1 cubit. So the blocks there were 1 cubit high. So now this is a cutaway drawing. I have a copy of this drawing on a big board outside if you want to come look at it more closely. But first the workers excavated this tunnel down into bedrock about 100 feet below bedrock and started carving out this subterranean chamber. And that was abandoned for some reason. We don't know why. And then they started erecting the pyramid and then built the Queen's Chamber here, the Grand Gallery coming up to this, and then the King's Chamber up here. And above the King's Chamber are these 5 chambers which are called relieving chambers. And the purpose of those was to transfer the load of all this weight of stone above the King's Chamber, transfer it off to the side so it didn't cause the roof of the King's Chamber to collapse. So this is a tunnel going down to the subterranean chamber. You could all walk down there. You have to kind of walk like this. It's about 3 feet high. And when you get down into the lower chamber, this is what you see. It's a big rectangular room. On the opposite end, it's all nicely finished. It's carved out of limestone. This is the west side of it, and you see here it's not finished. The workers stopped working right about this point. This is the ceiling. The floor would be down here, so here's material that had never been finished. Now try to picture yourself 100 feet underground, laying on your back, a little smoky oil lamp as your illumination, very little ventilation, and you're chipping here, and this limestone pieces are falling in your face. That had to be really hard work. And all that had to be carried up that tunnel and out of there. And the Queen's Chamber looks like this. These are large granite beams, very beautifully polished. This is the entrance here. And this was never for a queen, by the way. It was probably intended for the pharaoh, but for some reason never was used. And then this is the grand gallery. It's a very tall ceiling, corbelled ceiling, that leads up from the Queen's Chamber to the King's Chamber. And then here you see the King's Chamber. Here's the sarcophagus as it was found. It had been broken into ages before. No one knows what happened to Khufu. It's broken on the corner. The lid's gone. The coffin's gone. No remains or nothing was ever found of the Pharaoh Khufu. And these are granite blocks on the side and granite beams over the ceiling. There are 9 of these beams. Each one of those weighs about 45 tons. And those were cut out of that stone and asphalt and brought by boat 500 miles down the Nile River. Again, here you see the relieving chambers and how these were stacked up to protect the chamber. So now I want to come to the conclusion, the main thing that I was interested in, and that was to answer the age-old questions of how many workers did it take and how long did it take. And the conventional wisdom actually goes to this gentleman, to Herodotus, in his book, The Histories. And he wrote about the pyramids after visiting Egypt about 1,000 years after they had been built. And they were already, of course, abandoned. He came there as a Greek tourist. I'm sure he spoke to tourist guides who were probably the ancestors of the same ones you and I saw when we went there. And they told him some wild stories, but he was able to see some things that don't exist today, like the mortuary temple and the corridor leading from the mortuary temple down to the valley temple. Those things are all gone today. But in his book, he writes that it took 100,000 workers working in 3 shifts, 30 years to build the Great Pyramid. So that number had been quoted frequently. You probably see that in some modern books. And that was the thing I wanted to really take a look at is, well, how long did it take and how many workers did it take? And so I was struggling with how to do this. And actually what happened was we had a job to work on an extension of the BART system up in Northern California, the BART subway system. And I ended up having to be stuck in a motel up there for weeks at an end and not much to do. So I started thinking about this, and I thought, well, we ought to approach this question of how they build a pyramid the same way we would do a modern public works project today. We'd look at it in the same manner. So what that involves is developing something called a work breakdown structure where you list all the different tasks that have to be done on any particular job. A simple example would be you're going to build a brick wall. You have to dig a ditch. You have to make a foundation, a footing for the wall. Then you have to put the blocks on and maybe paint it at the end. And then you have to determine the order in which those things are done. So that's what we call a logic diagram. And obviously you can't pour the footing for the wall until you dig the ditch, and you can't place the blocks until you do the footing and so on. And when you look at a complex structure, there are lots of things that have to be done in a certain order, but there are other things that can be done later or earlier, and it doesn't matter what order they're in. So anyway, without boring you with the details of that, this is what I put together for the work breakdown structure. Now, a lot of people laugh when they look at that. They say, well, real estate, Actually, the Pharaoh owned everything. But if you think about it for a moment, it makes a little more sense because here this is done at a raw desert site. So, imagine going out to the banks of the Colorado River somewhere and say you're going to build this mammoth structure. Well, you have to have roads, you had to have a harbor, you had to have a town, you had to have housing. You're going to have thousands of workers there in the middle of the desert. You have to have a way to feed them, get the materials to them, get tools. So there was a lot of logistics to make this happen in the first place. And then the logic of how you do things. Anyway, when you put this all together, I use something called Primavera, which is a computer program well known in the construction industry. And you put together the tasks, you stipulate which tasks have to follow and which tasks have to proceed, and how much labor it takes to do each task. So I had to develop a computer model that would tell me, okay, for each of these 2.3 million blocks, how much time did it take to get them in place, how much labor, how long did it take? Obviously, it took longer to put a block up here than it did down here. Anyway, that all goes in, and fortunately, a computer can crank that all out and end up with a schedule that looks something like this. And these red lines are what's called the critical path. In other words, those red lines determine how long it takes to finish a job. If one of these red lines gets longer, the job gets longer. If a green line gets longer, it doesn't matter. And this is the final result then. And this shows the workforce, and it reaches up to about 25 or 30,000 people. Interestingly, only for about 3 years. And that's the time that corresponds to placing the majority of the stones and all the bigger stones. And then it falls off, and the job is done basically in 10 years. This is sort of what the site looked like. Here's the quarry, the ramps, the pyramid being built. Later, this is where the Sphinx would be, and these were where the next two pyramids would be. Here you see a canal and a harbor used to bring in materials. So in concluding, what can I say about this? I think the thing that intrigued me the most was the logistics of it, how the Egyptians could pull all these resources together in a timely manner to make some giant project like this happen. And when you think about it, they didn't have cell phones, they didn't have Blackberries, they didn't have pagers, but they had a marvelous administrative system. They had to have raw materials and labor come from all over the country. Lumber came from Lebanon in rafts down the Mediterranean Ocean. Copper from the Sinai Desert. So it was a tremendous accomplishment. And one final note, in one of the tombs that Nancy and I crawled into in our explorations, we came across this granite sarcophagus here that had been robbed thousands of years ago. And you can see here the lid of it. The lid probably weighs 2 tons, and it's been propped up by a wooden mallet so the robbers could get in and take whatever they took, which was everything as far as we know. There was nothing in there when we looked at it. And then in their haste, they went off and left the wooden mallet behind. So this sort of symbolized to me what happened to the pyramids, because the pyramids, in effect, were like big road signs, dig here. They were all eventually robbed. They failed in their main purpose of protecting the remains of the pharaoh. And so eventually this period of several hundred years, 500 or 600 years of building pyramids faded away, and then the Egyptians started burying their dead in places, hidden tombs like in the Valley of the Kings. And of course, even those were eventually robbed. So with that, I thank you very much. I'll be glad to try to answer any questions. And again, outside, if you're interested in the books, they're there. The books, by the way, the sale of the books benefits the Bowers Museum, one of my other favorite institutions here. It's been very diligent in bringing great things from Egypt to us so that we could see them here in Orange County. So thank you very much.